go. Brilliant. So, so I've got a sheet here. It's actually one from last year, but it's very similar to the stuff we're doing now. Do you want me to send you this, or are you okay to write it in your back of your book, or?
Could you send it to me and I can print it off?
Oh, that's nice. Brilliant. Yeah, that's great. Okay, so I'll do that now. Well, I'm just going to write a couple more Surds questions here.
That's fine.
So root 3 plus 2 root 2 squared. And let me think of another one. Insert. Make it wider.
Have you sent a message to Jay?
Yeah, she said she can't make it for some reason. I'm not sure why.
Yeah, I thought we were starting later today than we were.
Oh, sorry. Is this a bad time, or do you want me? I can.
Oh no, but I thought we said we were starting at 1:30 because Jay was in dance or something. I don't know.
Well, I'll message her maybe at 1:30, see if she wants to join then. Yeah, that's strange. That okay. Sorry. I'll do root 3 plus. I'll tell you what. No, I'll make that 2 plus root 5. No, so 2 plus root 5. There you go. So a couple more Surds questions for us to do that. So I'll send this over now. Let me just save it somewhere logical. There we go. So I'll just send this over to you now. It's probably best as a PDF, so I'll export it as a PDF actually. And there we go. I've just sent it to you now. Okay.
Okay.
Yeah, so you can print it off if you want. That's absolutely fine. I'm sorry. I would have sent it too early if I'd realised. Sorry about that.
That's fine.
And is it letting me write? Yes. No, it's not letting me write. Sorry, 1 sec. It's not letting me write. There we go.
Wait, are we going through this sheet you're sending me like now?
Yeah, is that okay? Or
I'll just do it in my notebook then.
it's okay. I mean, honestly, if you want to print it off now, that's fine.
I thought you meant like a different, like to print it off a different time because my printer's broken at the minute.
Oh, okay. Is that okay? So you mind? Sorry about that. I'm sorry to be a pain.
No, that's fine. I'll write in my notebook. I've got my notebook out anyway.
Okay,
so.
brilliant. Okay, so the right. So I'm not really worried about the first one. That's not really relevant to us. So the second one is though. So the second one is compound interest. So Rob invests £200 for 3 years at 5% compound interest, and that PA stands for per annum. So that just means per year.
Yeah. Hold on.
No problem.
Where is that? Okay, I'm fine now. Yep.
Okay, that's fine. So there we go. So we want to work out how much he will have in his account after 3 years. Okay.
Okay.
Now I know I've taught you the proper way with the formula, but without a calculator, it might be easier just to work out how much he has at the end of each year.
Mm-hmm.
Okay. Oh, so I've got it on. That's what was happening. I've got it on shape mode. There we go. It's trying. Whenever I draw, it's trying to make it into a shape. That's why I don't want ink to show. I want that off. There we go. Sorry. Okay. That's where the arrows are coming from, I guess. Before. There we go. There you go. So I want to work out how much he will have at the end of the first year. So how could I work out how much he will have in his account at the end of the first year?
Mm-hmm.
So what would I have to do to work that out?
Hold on, I was just writing the question quickly.
Oh, that's no problem. Oh, that's fine. Take your time, Kendra. That's fine.
Okay, yeah.
Okay.
I've written the question now.
Lovely. Okay, so we want to work out how much he will have after 3 years. So first of all, how could we work out how much he'll have at the end of the first year?
Hold on, I'm writing it down. We'll do 5%. Need to find 5% of 200.
Yeah, brilliant. So it might help if we find 10%
10.
first. Yes, excellent. So
Answer
what's
10. I was
10%?
doing it on my sheet, yeah.
Oh, so you've worked it out already. That's fine. Yeah, 5%
No,
is
I was
10.
doing like the 10% thing, yeah.
Oh, lovely. Lovely. So 5% is £10. So the
So I have
end
a
of the
question. Is it going up or going down? Because it doesn't really say.
well, it's compound. That's a good point, actually, but it's compound interest. That always means going up.
Okay.
Because if something earns interest, it's growing. That's a good point, actually. It's only going down if we see depreciation.
Okay.
So how much is he going to have in the bank at the end of the first year? So after that 5%,
210.
lovely. So 210. So that's at the end of the first year. Now,
And then the third year would be 230.
right. So
Oh,
now
no,
I
I
can.
wouldn't. I messed up. I know I've gone wrong now. I get it.
Yeah, it's compound interest, not simple. Good that you realised it. So
Yeah.
we've got to go through that horrible process of doing 5% again. So 5% of 210. How would we do that?
10%. And then divide that by 2.
Yeah.
Is it 10.5?
Yes, because 10% is 21. Halve that, you get 10.5. Yeah, lovely. So it's £10.50.
Yeah.
So you can see that it's actually grown by 50p more than it did in the first year.
So if I was adding it on, I would add the whole 10 and the 0.5. Yeah.
Yes, of course. You've done all of this because it's compound interest. It grows by a little bit more every year. So we add that on. So we do 210 plus £10.50, which is £220.50. Okay, so end of the third year, how are we gonna? Well, it's the same process, isn't it?
20.
So
22.5, like 0.5, or is it?
yeah, so 22.05 is 10%, so we've got to halve that, and that should give us 11.025. Yeah.
I suppose it would be right at 11.03 as its money.
Well, I think that would probably be fine, but I think it's best to always round at the end. Okay, so we'll leave that for now.
Okay.
We'll round it at the end. But that's a good point, actually. So at the beginning of the third year, he's got £220.50, and we add on 11.025. Okay, so there we go.
231.025.
Yeah, so there we go, and then obviously 231 point. I get 525. What do I get? So
Huh?
at the end of the second year,
Yeah.
I think he has £220.50.
Yeah, that's what I got.
Yeah, so then if we do £220.50 plus 11.025, I get
231.025.
point. So can you see my screen, by the way?
Yeah.
Yeah, so I get a 5 in the tenths column of the 220. So 5 plus 0 is 5.
Hold on.
I think at the second year you only added on 10. You got to add on 10.5.
Oh, I thought I did add it on. I guess I didn't.
That's okay. It's easily done. Don't worry, Kendra. So we have £231, and then we would round because it's the final answer. We'd now round it. 0.53.
Mm-hmm.
Is that okay?
Yeah.
Now, I think, if we did it with a calculator, we could literally just do 200 times 1.05, the multiplier, to the power 3. And if we did that, we would get exactly the same answer. Okay?
Right, yeah.
Okay, but we have to do it this way because we haven't got a calculator. Okay.
Mm-hmm.
Right. So before we move on, I'll just ask: is there anything which you're really not sure of? Because I've got the revision list here somewhere. Sorry about that. I've got the revision list here. Is there anything on here which you're really not happy with? So because I'm happy to go through the whole sheet, that's not a problem. But just to help you, really. So,
Let me find it.
I think I did give this to you. I'm not sure if I think I put it's on Teams anyway. I think I printed it off for you guys, but I think I need to give you tomorrow. So, is there anything there which you're really not happy with? So we've just done compound interest, by the way. So I think we're fine with that one.
Okay. Let me take a look.
Yeah. So number 6 is like that one we did with the 5/11ths, the 7/11ths on the revision sheet.
Oh, yeah.
So
Yeah.
that one I can, if I get the revision sheet as well, that will be useful for you. So the revision sheet, this one. So I can basically show you where they sort of correspond. So sort of follows the order. So there's obviously compound interest. Then there's the standard form stuff. So adding, taking away, in standard form.
Prime factors, yeah.
Yeah, then there's prime factors, find the highest common factor, lowest common multiple. There's that business with the why is this not a square number?
Yeah.
There's a bit of reverse percentage or multipliers, and then there's the reverse percentage. You've got your upper and lower bounds, recurrent decimals, and then there's inverse proportion. And there is a little bit more. There's also exchange rates, indices, and surds, but that one wasn't quite covered on that sheet. I'll have to do that tomorrow with you guys. Okay.
Okay. Could maybe we do surds again?
Yeah, we can do surd by all means.
That's okay.
So that's absolutely fine. So we'll go back to this other stuff, but right now we'll have a look at surds. So that's not there. It must be on the one. I don't want to say that. It must be on the new one that I saved. Yeah. No. Well, it's certainly somewhere because I know I just had it now, so it must be here. No, it's not there. Okay, that's fine. We'll make some surd questions. So basic kind of questions you got on surds. There's one because as I said, a couple more surds questions have been added because the AER question's been removed. So that means I've actually got to staple a new page to your tests, which will be fun. So
I feel like it was a certain type of surds question we were doing I didn't understand.
Yes.
So there was the one we were doing. Was that surds the one we were doing last lesson?
Yes, like root 3, take away 2
I got
all
that,
squared.
but I didn't understand the other stuff we were doing.
So root 3 minus 2 all squared, that one you were happy with the grid, yeah?
Yeah, I can do that one.
Oh, I know what it is. It's this, probably. It's like 15 over root 5, and you've got to rationalize the denominator.
Yeah, I think it was that one.
Yes, well, I'll tell you what you can actually do, you should be able to look at the top. Can you see the top line where it actually writes it neatly?
Yeah.
Yeah, so that hopefully should work. So 15 over root 5, well, if I want to get the bottom to be rational, what have I got to times root 5 by to just get 5?
5?
Nearly. root.
Root 5, damn.
Yeah, you've got to remember, it's okay, root A times root A is equal to A. Okay, so I don't my
You times both sides by it.
So, right, let me just write this down. So let's say we want to do a couple of rationalizing. So what I'll do, I will say we've got 15 over root 5. I'll say we've got 16 root 2 over root 2. Not root 2, I'll say that's root 8. Let's say we have 5 root 3 over root 3, or maybe I'll make that a 9. Work out 27. So you might have questions like this, okay, and that is a 6. There we go. So I'll insert that now. Then we'll have some nice Surds questions. There we go. So the aim of these is to make the bottom, because there's no actual question. The question is to simplify it, but people don't like it because they think, well, it doesn't look any simpler. But the aim is to make the bottom into a whole number. Okay. So we need to remember basically that root A. Sorry, it's not letting me write again. It's been like pain. Nope, it's not letting me write again. There we go. Now it is. Okay, so basically, right, so the aim is to get the bottom to be a whole number. So I've got 15 over root 5 to start with. Okay. Now remember, root A times root A is just A. Okay.
Yeah.
So we have to times the bottom by root 5.
Do we have to times the top by root 5 as well?
Excellent. Yeah, of course, because whatever you times the bottom by, you have to times the top by to keep the fraction the same. So what are we gonna have on the top? Because we can't actually simplify that. That root 5 is like an x. If we had 15 times x, what would that be?
15x?
Yeah, so that's just 15 root 5. You can't bring that 50 under the square root because there's no square root there. So in order to bring that 15 underneath the square root, it would have to be square root 15, which we don't have. So we have 15 root 5 over 5.
5.
Now, is there any way we can simplify that now?
I'm not sure.
Well, we cannot. The root 5, you can only sort of manipulate square roots with square roots. So the only square root there is root 5. So I cannot mix that with the 15 or the 5. But the 15 and the 5, they share a common factor.
Yeah.
So what number goes into 15 and 5?
5?
5. So what I could do is divide the bottom by 5 to give me 1. And then if I divide the bottom by 5, I want to divide the top by 5. And what is 15 divided by 5? 3. So that means I just have 3
square root 5 over 1.
Yeah, which is just what happens if I divide something by 1?
It's the same.
It's the same. So my answer is just 3 root 5. So sometimes you actually end up getting rid of the fraction. It simplifies so far that it's just a number.
Okay. Yeah, that's fine.
They're not, well, it's not too bad. It's an easy method. You just times top and bottom by the bottom, but it's not particularly nice. I can agree with that. So if we have a look at the second, if we have a look at the second one, so 16 root 2 over root 8, what would I have to times the top and the bottom by?
Root 8.
Good. It's always the denominator that you times top and bottom by. So this time, we do have 2 square roots. So we need to remember root A times root B is just root A times B.
Okay.
So when you have 2 square roots, only when you're timesing or dividing, you can't do this when you're adding, we can sort of combine them. So I can end up with 16 root, well, I shouldn't put that in green. I'm going to have 16 unchanged times, and then I'm going to combine the two surds with that law here. Root A, root B is root AB. And I get root 2 times 8.
Okay.
And all of that is now going to be over
8.
8. Brilliant. So we have, right, 16 times. Right, what is 2 times 8?
16.
16. So it's 16 times
16 squared.
square root.
Yeah, but because I don't know.
Well, I know. Well, what you're saying is, you're saying this. I've got 16 times 16 is 16 squared. I agree with that. That's totally right. But we don't have 16 times 16 here.
Wrong context.
Well, we have 16 times root 16. That is not 16 squared.
16 times 4.
Yes, that's totally right. It's 16 times 4. So we have
64.
16. Yeah, 16 times 4 over 8. So yeah, we can do that, which is 64 over 8. Now, which is just 64 divided by 8, which is...
You could divide that by a number. You could simplify that.
Sorry?
You could probably simplify that, though, couldn't you?
Oh, you mean simplify it at an earlier stage? Yeah, we can do that. We can do that here. So it is 64 over 8, or we could say, or we could say, 4 into itself goes once. No, even better yet, we could say 8 into itself goes once, 8 into 16 goes twice.
Isn't 64 divided by 4 16? So wouldn't it just be like...
Well, so think, right, so are we happy with everything up to this stage when we get 16 times 4 over 8? Okay, so you can either...
I think it's just the simplifying that confuses me on this.
Well, we don't need to do that at this stage. We can just work out the top and divide it. But basically, I've got 16 times 4 over 8, so I can say 8 goes into itself... Oh, disappeared. 8 goes into itself once. 8 goes into 16 twice. Does that make sense, what I've done there?
Yeah.
Right, so I now have 2 times 4 over 1, which is just 8 over 1, which is 8. So my final answer would be 8.
But if I wanted to simplify it, but we already had 64 over 8.
Oh, that's the same. If you do that, you'll get the same answer. 8 into 64 goes 8, so it's the same.
Okay.
It's fine, because you haven't broken any rules, you'll get the same answer. It's just which way is quicker for you, which way you prefer. You know, I think in all honesty, when I was in year 10 or 11, I'd probably do 16 times 4, 64, and then divide it by 8. That's fine. As long as you don't break any rules, it's fine.
Okay.
Is that okay, though, Kendra? Does that make sense?
Yeah, that's fine. Yeah.
Well, that's brilliant, because basically you've got there's like a 3 or 4 marker, I think, and it's to do with using all of these rules in one, basically. So you've got, it's something like, I don't know, 5, I'm trying to think, maybe like 6 root 3. These numbers might be horrible because I'm just making it up now, but this is something towards what it looks like. 6 root 3 plus, I don't know, 5 root 12 over 2. Hang on, so root, no, that's not root there. Root 1244. Make that a 3, that'll work. Root 3. So it's something like this, right? 5 root 12 over root 3. All of that over something like root, yeah, all of that over something like root 18 or something like that. And it basically asks you to simplify it, okay? So it doesn't look particularly nice, does it?
No.
No, but we can think of it.
Oh, we did this. We separated it into parts. I remember this.
Yes, this is why I did that. So we can think of it as A, B. I don't know why
I remember this.
I don't know why that's so incorrect.
I was good at this one. I could do this one.
Yeah, you were brilliant at it. Yeah. So A, B, and then C. So we could think of it that way. So if we simplify A first, Actually, I don't think we can. A looks different to that. Oh yeah, it was this. That's why it was something like that squared. So if we think about that, so how could we simplify A? 6√3 all squared.
Okay, hold on.
So we haven't got to do it in one go. Just think about what it means to square a number.
Will we just? Oh, I don't know actually.
Well, don't panic about it. If I have 6 squareds, are we happy that's 6 times 6?
Yeah.
So 6√3 all squared is just 6√3, which basically it's this. It's 6 times √3. That is 6√3. And it's going to be times by another 6 times √3.
Oh, I remember this now.
Just
Yeah,
write
I
it
get
down.
this. I get this. I remember this. I do remember it now. Is it 12 within the square root 6?
So it's 6 times. First of all, we've got 6 times 6, which is 36.
It's 36, yeah.
Yeah, I think you added them. That's a really common thing. To do 6 times 6 is 12. It's a really common thing. But just remember, 6 times 6 is 36. And then I've got the square root parts, because I can times them in any order, because all I'm doing there is times in. So √3 times √3 is just 3. So I have 36 times 3, because I've still got the times in the middle. Okay?
Okay.
So, there are loads of ways of working out 36 times 3. I mean, you might I think you do the columns, I think, don't you?
Yeah, hold on. Let me do it.
That's fine, no rush.
$108?
Yeah, I think so, isn't it? So 90 and then 18, 108. Brilliant.
Yeah.
Okay. So that bit, so A, we know is 108. So we could now replace that 6√3 squared with 108. Okay, but we won't do it yet. We'll just do A, B, and C. So part B then, we want to simplify 5√12 over √3. Okay. So we want to basically rationalize the denominator. So what would we need to multiply the top and the bottom
By 3 on both sides. Root 3.
Times √3, yeah, times top and bottom by √3.
Yeah, that's what I said.
Yeah, thank you. So what are we going to have on the top? So because I've got 2 square roots times on the top, what can we do?
Would it be 5? I don't, I'm not sure. I don't know. I was going to say, would it be 5 square root, like 3 times 12? I think that's wrong.
That's right. No. That's totally right. Whenever you have square root A times square root B, you have the square root of A times B. So you have 5 times the square
48
root.
square root.
Nearly. 12 times 3 is?
Oh, I don't know my 12 times.
It's fine. 3 times 10 is 30. Plus 3, 33. Yeah. Plus 3 again, 36.
Yeah, I know it's 36, isn't it? I thought it was 30. Oh, yeah, it's 30. Oops, I get mixed up, the order mixed up.
No, that's not a problem. That's fine. Okay, so we have 5 times root 12 times 3 over. Well, what is √3 times √3?
It's just 3.
Good, brilliant. So we have 5 times root 36 over 3, which is 5 times what over 3?
16? No, that's wrong.
What's the square root of 36?
It's... I'm trying to think.
So just maybe cycle through your square numbers. 1 squared is 1. 2 squared is 4.
Oh yeah, 6. Oops.
Brilliant. So you got 5 times 6, 4 over
Damn.
3. And then it's fine. So and then at this stage we can do what we did earlier and we can simplify. So 3 goes into it.
30 over 3.
Yeah, we can do that too. That's fine. So 30 over 3 is
Um,
how many 3s in 30?
10 over 1.
10 over 1, which is just 10.
Yeah.
Okay, brilliant. So that horrible looking surd is actually just 10, and that happens quite often in things like you do get things like that in like special relativity because in special
So would C be
Einstein's
9?
You're thinking of root 81.
Oh yeah, damn. I didn't.
That's
Oh
okay.
yeah, damn.
Looking at the way, that's fine. That's not a problem. So, and again, because 18 is 2 times 9, it's very easy to see that. Our brains sort of make these connections, and then we just go because you've learned so much in the past. If you go from year 8 to year 11, so much has been crammed into your head. Things are going to get crossed now and again. So, part of revision is sort of uncrossing some of those things.
Yeah,
So
it's the number. It's just the numbers a bit flipped.
yeah, on the screen maybe it's flipped. It isn't flipped on your screen though when you're looking
No,
at it.
it's not that it's flipped on the screen. It's just my brain just flipped the numbers around.
It does happen. Yeah, it does. It can happen. I mean, if you find that happening a lot, you can use one of my overlay. You have an overlay if you want to use one, but I don't think you need one
Oh
really,
no, it's
Kendra.
fine.
No, I know because
It's nothing to do with that.
no, because I know you're very good with your literacy and your numeracy and everything. So that's not but it's always there if you want to use one. So the first
Okay.
so the 6 root 3 squared 108. The 5 root 12 of root 3 was 10. And on the
Mm-hmm.
bottom, we have root 18. So we end up with, this is probably harder than the test one. So what have we got on the top?
118.
118. So 118 over root 18. So how
So we keep the C the square root, do we?
well, we're not finished yet. How can we simplify this now? Because we're at this stage with 118 over root 18. How can we simplify that? What would we have to do to the denominator? Because I don't want a surd on the bottom. I don't want to divide by a surd.
Oh, could you say that again, please?
So I don't want to divide by a surd. So how can I make it so the bottom isn't a surd? So I need a new page. So I've got
Times it by square root 18.
yeah, because it's 118 over root 18, so I just times top and bottom by root 18. Brilliant.
Okay, hold on.
That's great.
Okay, I've got that written down now.
Brilliant. So we have so how are we going to simplify this further now? Because it's only like 2 more steps.
Oh, hold 18 divided by 18. So we have 118 and then square root 18 divided by 18.
Brilliant. So
There's a lot of 18s.
yeah, I don't know. That just worked out that way. Strange. So can we see anything that goes into 18 and the 118 here? Are there any common factors here?
8?
I mean,
I
yeah.
don't
So,
know.
can we do
I
that?
was a guess.
Yeah, we're not allowed to do that. What I just did there. No, you
Damn.
can't do this. It's like when you see jokes
I
on the
know
internet about
2.
things like this. 2, yeah, you have jokes on the internet like this. You're not allowed to do that. So yeah, it is definitely 2. If they're both even, so we could halve the bottom, halve the top. So on the bottom we're going to have 9. On the top there, we've got half of 108 is right 50 plus Well, think of 100. If I halve 100, I get 50. If I halve 18, I get 9. So I should get 59.
Okay.
Now there's a lot of 9s. And that's, I
Okay,
think
so
that's as far as we can go, because 59 is a prime.
we can't square root 18 then, can we?
No, because it's a surd. Now, it's funny that you mentioned that. There is actually there's another step we can actually take. And this is a bit of a head stick, because I want to go through this with you guys tomorrow, where you actually
Okay.
have a square root and you simplify it. So we can actually go further. So if you remember, the square root of a times b was the square root of a times the square root of b. Yeah, so root a times b is root a times root b. Yeah? Okay. So if we have, if we have the square root of 18, well, can you think of two numbers that times to give 18, and one of them is a square number? Think of the numbers that times to give 18.
2 times 9.
2 times 9, that's the one, isn't it? Because these are the factors of 18. Now, 18 is equal to 2 times 9.
Yeah.
So we can basically make we can make the a into 2 and the b into 9. And then we basically have that root 18 is root 2 times root 9. Can you see what I've done there?
Yeah.
Okay, so we end up with, well, what is the square root of 9? Because you were asking what the square root of 18 was. What's the square root of 9?
3.
3, brilliant. Yeah, that's 3.
Okay.
So we basically have root 2 times 3, otherwise known as 3 times root 2.
Okay. Well, I gotta write this all down quickly.
Yeah, that's fine. I mean, this one's harder than probably the test one, but it's still good to practice, definitely. And it is, they are useful, these laws of surds. They are when if you do things like special relativity, there's a lot of square roots involved, and it does help you.
Okay, I've written it down.
Brilliant. So we end up with 59 times, now we know root 18 is actually 3 root 2, so we have 59 times 3 times root 2 all over 9. Now we can simplify that. If I look at the factors on the
59
top,
times 3, isn't that like 170 something?
well, it's going to be 150 plus 27, which is 167.
Oh, that's close.
No, you were very close. 150, yeah, and no, you were actually closer than me, because it's actually 177, which is closer to what you said. Because 50 times 3 is 150, 9 times 3 is 27, 177. But I think there's something we can do to avoid that. If we look at the numbers in the top, they're all being times, so I can just cancel tops and bottoms, basically. So if I look at 59, that's a prime, so I can't cancel anything there. If I look at 3 and 9, is there a number that goes into 3 and 9?
3?
3. So I can just say 3 goes into itself once. 3 goes into 9. How many times?
3.
3. So that leaves my answer as 59 times 1, which is just 59, root 2, over 3. And that is as far as we can go.
Oh, so that's the most simplified you can get.
Yeah, there's no way to go further, because 59 and 3 do not share any common factors, and root 2 is a surd in its simplest form.
Okay, right, okay, that makes sense.
Yeah, so that's a bit of a monster. I think that would easily be 6 or 7 marks. That would have to be. Or maybe not 7 marks, but like 6 marks
I
easily.
probably need to like remember all the stuff, so I need to remember like A
summarize.
times B.
Well, look, I mean, let's write it in a little box. This is how I learned surds.
Yeah, that's what I was doing earlier. I was taking notes and writing it in my notebook.
I mean, I feel I don't do that enough, but I mean, the way that we're trained to teach now is more that you understand it, and that's good. You should understand it, but there's nothing wrong with having a box or even having little post-it notes and putting them on your wall. That's what I used to do. I used to have a periodic table on my wall. I had the German adjective endings. I had like the sine, cosine graphs. I had loads of stuff when I was like your age on my wall. I mean, you can take it down. You can take it down when your friends come over. It's not a problem. But if you've got, because essentially,
My friends don't come over.
I'm sure they do. I'm sure Jay does, but
Especially not with this pandemic.
No, that's the thing. Yeah, but there we go. So, I mean, basically, the rules of surds are root A times root B, root A times B. You can bring them in. Root A divided by B is root A divided by root B, but in all honesty, we don't really, the way I've taught it, we don't really use that. Then if you've got 1 over root B, or if you've got, say, A over root B, well, to get rid of the root on the bottom, you times top and bottom by root B. And what is root B times root B on the bottom?
B.
B. So we end up with A root B over B. So that is rationalized in the denominator. So if you have those, that's pretty much all you need for surds.
Yeah, I've got those written down.
Yeah, and those are the rules, basically. As long as you understand where they come from, that's fine. Those are the rules. There's nothing wrong with doing rules. And that's actually you need to learn rules. That's a big part of maths. So if we look at, there's a couple of other kinds of surds. There's another kind of surds question where they'll basically say to you stuff. Oh, hang on. Let me try and, because I can send you these notes. See, Kendra.
Oh, that's fine.
Well, it's up to you. I mean, you keep your own notes, which is good because then it sticks in your mind better. But just trying to make a new page for myself. There we go. Okay, so you might have a question like this. So it literally just says simplify, and it will give you a square root. So it'll say simplify. I'm trying to think now of a square that I can do this for. It might even be simplify root 27. But well, 27 is a cube. It's not a square. So what am I going to do? Well, you think of the factors of 27. So the method is factors of 27. And then ask, are any of them square? Because if any of them are square, that'll be a really good candidate to put in the square root.
Would 3 count as one? Or am I wrong?
3 is a factor of 27, yes, but is 3 a square number?
I'm not sure.
Well, can I square something to get 3? Can I square a whole number to get 3? No. So basically, well, think of another one. What other numbers go into 27? We can think about it systematically. 9, that's the one. Yeah, so we don't need to. So 27 is equal to what times 9?
3.
3. Okay, right. So now we can keep that in mind. And basically, that first rule of surds, root A, root B is root AB, we can make use of. So 27 is 3 times 9. So the square root of 27 is the square root of 3 times 9.
Mm-hmm.
So that's going to be root 3 times root 9. But what is the square root of 9?
3?
3. Yeah, it is 3. And well, think about it now. 3 squared is 3 times 3, which is 9. So if 3 squared is 9, the square root of 9 is 3. So that means root 27 is really root 3 times 3, which is just 3 root 3. So 27 is really just 3 lots of the square root of 3.
Okay.
And that's useful because it helps you estimate square roots. Because, I think, well, 3 is between 4 and 1, closer to 4. Square root of 4 is 2. Square root of 1 is 1, so that means root 3 is somewhere between 1 and 2. So let's call it 1.5. 3 times 1.5 is 9 over 3 times 1.5 is 9 over 2, which is 4.5. So then I reckon, based on that little calculation in my head, root 27 will be about 4.5. Right? That's what surds allow us to do. So if I check that, it's probably nowhere near now, but let's see. Root 27 is, okay, 5. So, I said 4.5. It's really about 5. That's not a bad estimate for a square root, is it, really? So that's what surds allow us to do.
Okay.
You've got to think, before calculators, that was extremely useful. Because it basically let you take you could have a massive square root and you could simplify it down, and then you could have little chunks that were much easier to work out. And it might not seem to be relevant now, but it does come into play when you're looking at algorithms on a computer, because you want the most efficient algorithm on the computer. So it's important to understand these methods for that. Right, so if we look at a trickier one, so you might have one like square root. I'm going to try and think of a really weird one. So square root of 784. You might have one like that. I actually think that is a square number. Actually, I think I've just written it's like 27, not 27, so 28 squared. I think that is a square number. I'm gonna do it on my other monitor. There we go. It is. That is actually. Oh my gosh! I actually did pick a square number. It is 28 squared. Well done. Sorry about that. Okay, let's pick one which isn't a square number.
No, it's fine.
In all honesty, it lets you. It's a way of working out square roots as well. You can use surds to help you work out square roots. But I'm trying to think of which isn't a square. So what about 364? So we might have something like that. Find the square root of 364. So, or not find the square root, but simplify. So can we think of a square number that goes into 364?
2.
2, but now 2 is not a square. That might help us.
Oh, damn.
So, well, what square numbers do we know that might go into it? No, 2 is not a square. So 4, maybe?
Yeah, 4.
You could give that a go.
I was trying to decide between 4 and 9, and I was like, wait, 4 makes the most sense now you said it.
Well, 9 possibly as well, but the thing with 9 is the digits would have to add up to a multiple of 9. 6 plus 3 is 9, plus 4 is 13. So 9 isn't going to go into it because of that, but we can try it though. So 3, yeah, that's always a nice little trick, by the way. If I have 270.
Well, I've never noticed that before. That's quite cool, that is.
It is quite cool. So 9, 9. If I add 7, 8, 9, 18, and then 19. If I add 8 on the end, right? That I guarantee 9 will go into that. So let me check. 9, 10, 11, 18, 19, 20, 21, 22, 23, 6.
25, isn't it?
Right, I guarantee 9 will go into this. Because the digits add up to 9, right? 7 plus 2 is 9. Plus 9 is 18. Plus 9 is 27. So if you add up the digits into a multiple of 9, 9 will go into it. So 0, 2, 9, 1, 1. There you go. A more impressive one would probably be something like 800 and... I don't know, there are more impressive ones. So the point is, that's a nice little trick. It works for 9 and it works for 3 as well. So, right, so 4...
it doesn't work for everything.
It only works for 3 and 9 as far as I know. Yeah, it's a strange... It's got... the way I proved it, I remember I did a proof of it before, and I think it was to do with the way that you could write them as decimals. If you write the way you write a multiple of 3 as a decimal expansion, and you can basically show that the sum of the digits must be in the 3s as well. So if we do 4 into 364, we get 4 into 3 goes 0 into 3, 4 into 36, 9, 4 into 4, 1. So it actually does go. So we can write root 364 is equal to root 4 times 91, which is root 4 times root 91. And what is the square root of 4?
2.
2. Now, the thing is, 91 is a prime, so I don't think that can go any further. So we've literally got 2 root 91. And a modern calculator should be able to handle that. So if I do root 364, 2 root 91.
Oh.
Okay. It's a good way of checking. I mean, the old calculators wouldn't be able to do that. The old ones would do, because when it's doing that, it's doing some sort of symbolic algebra behind the scenes, whereas an old calculator would just sort of, there's a really nice approximation of a square root that you can just remember, and the calculator would basically do that to a certain degree of accuracy. But again, this gives us an idea for estimating it because, I know that 9 squared is 81, 10 squared is 100, so I know root 91 is going to be somewhere between 9 and 10. So I could say, it's about 9.5. 2 times 9.5 is going to be 19. So my guess there is that the root 364 is somewhere around 19. So root 364, somewhere about 19. 19 exactly, pretty much. So yeah. So you can see that it's quite powerful because square roots look like this impenetrable thing. I can't work out a square root, but using Surds, we can estimate them, and that can be really useful. Okay, so do you want to look at another one, or is there anything else? If we have a little look at the revision sheet, the one I did a few days ago, and we'll see then if there's anything which we're still not happy with. Okay. So compound interest, would you say happy with
I'm
that?
good with that.
Yeah, that's great. No issues there. Standard form?
Yeah, I'd say I'm pretty good with standard form as well.
Yeah, we've done a lot of practice with that, I'm sure.
And the prime factors thing, I'm
That's
good
fine.
with that, with the Venn
Great.
diagram and stuff.
That's fine. So HCF times numbers in the middle, LCM times them all. For it to be so, can you tell me why 2 to the 25? How do I know that's not a square number?
Because the last digit of the indice is an odd number.
Yeah, excellent. Because all we need to say there is that the index or the indices are odd. So the point, you're totally right. You would get the marks there. It's basically not all of the indices are even. So it's something like you could have 2 cubed times 3 to the 4 times 7 to the 8. These both have even powers, but because that 2 does not, the whole number is not a square. They all need to be even. Okay, all the powers. Good. Multipliers, reduce by 15%, take 15% off. Increase, is that okay? Percentage increase and decrease. Reverse percentages, so I increase them by 30%. The new number's 260, find the original. Yeah, so we got that method.
Yeah,
There's a little
I'm
trick.
pretty good with that. Yeah.
Yeah, no, I'm sure you are, Ken. You are honestly doing really well. High hopes. So this
Upper
business.
bounds and lower bounds, the area ones. I can do these.
Yeah, excellent. So 2SF. You look where the second significant figure is. It's in the units. Half of a unit is 0.5. Add it on upper, take it away lower. Great. Okay.
Yeah.
There's no actual method for that. I have to sort of make that up because I can't find any. I can never find any. Nobody seems to know how to teach that, so I just sort of had to make that one up. So Bob earns 1,500. So this is a sort of money questions business here. So it's like an OCW question. You just have to have the subheading. So bills, rent, food, total, and then make sure you're understanding the question.
Yeah, could we maybe go over one of these questions?
Yeah, do you want to do the same one or like a similar one maybe? There's loads.
Do a similar one because I've seen the answers for those ones.
Yeah, that's a good point. So yeah, there's like ones that there's like all sorts of profit and loss ones on the numeracy papers now. So this would be definitely higher tier, and if I can't find you, I'll just look at a recent paper, profit and loss. That's question 8, so this must be quite hard. Waiting the ratio, it's not ratio. No, I want a hard question. That's the one. Okay, this one looks hard. So that's a hard question. But I want one with fractions as well. So fractions, percentages. Here we go. Oh, that's the one there. That's the one there. Okay, so this one, so that's quite an early one in the paper, but it still looks quite hard. That's a good one, actually. How much profit or loss? That's a good one. Yeah, there's a couple of good ones there we can do. So let me find where we are. 20. Yeah, these do look quite hard. So I think I'm not sure if these are calculator questions. These might be calculator, but we'll try it without. So, there we go. So right, so this is OCW, obviously. So and this is 8 marks. So 2 of those would be for your organisation and work-ins. So Jenny runs a stall at the local farmers market.
Okay.
Do you want me to send you
copy the
these?
question out.
Do you want me to send you these? Or, yeah.
No, it's fine. I'll copy it out.
Okay. So she makes 20 fruit cakes, 15 chocolate cakes, 6 half of the normal selling price. Okay, Kendra?
Yeah, I'm almost finished.
No problem.
Okay, I finished writing it.
Okay, brilliant. So,
I wrote the entire thing. I think I've got a hand cramp now.
oh gosh, yeah, I think, yeah, and it's probably like writing one of your history essays. There you go.
Oh no, RS is worse than history.
Yeah, so at least history is like you can be quite concise, I guess. You know, you got your
Oh no,
argument.
if you look at like you put like a GCSE history exam next to a GCSE RS exam, the RS one is a lot more writing than the history one.
Really? Blimey, that.
History one's only like it's 12 like normal questions and that one's an essay. But
Really?
RS is like a full page, two half a page questions, which you have to like that sound like an essay. One full page question and then a 2 page essay, but you have that 4 times in a 2 hour exam.
Oh, that's horrible. That is. I remember yeah, I mean, there was a lot of writing in history, but it was quite structured. I knew exactly what to write and where, so it was quite easy, really. I mean, there
I
was a
find
lot to
history
remember. I
easy.
wouldn't say history is not easy. It's brilliant, but it's not it's not
I
easy.
personally find it easy because I enjoy it.
Oh, it's interesting though. That's the thing. It's if it's something interesting,
Mm.
it's easy to remember. Absolutely. You know, that's 100%. You know, it doesn't feel like work almost. You know, I mean, and that's what you want to find. You want to find a subject that is like that. I mean, for me, I think physics was more like that at university. The physics modules were more like that. You know, I did nuclear physics in my last year, and quantum mechanics. I enjoyed all that more really. Some of the maths modules were harder to remember. It's just you've got to be interested in it.
Mm.
So, although I
Okay.
do like maths,
Where do we
obviously.
where do we
Yes.
start with
Where
this
do we start?
question?
So, I always start with profit and loss.
Highlighting the question.
Yeah, highlighting's a big thing, definitely. So if we highlight it, I can't highlight it, so I'll have to. I can actually. I can. I need to get it into Word. So for me to highlight, I've got to go into Words. There we go. So yeah, so we can highlight it. So, so 1 week she made 20 fruit cakes. So we can see obviously it's to do with fruit cakes and chocolate cakes. Okay.
Okay. Yeah.
Right. She planned to sell the fruit
I've
cakes.
highlighted the question.
Brilliant. So yeah, so she's selling them £6 each. Chocolate cakes £2, and the cost of making them was half the normal selling price. So what I would probably do is highlight everything to do with cost in red, maybe. So cost,
Yeah,
half
that's what I've
selling
done.
price. That's a good idea. And there's 70%. No, that's to do with profit actually. So that one, yeah, 70%, 3/4. Didn't sell them all. Sell the rest of them at that. Okay, so 13 of the chocolate cakes at full price and the rest at half price. Okay, so basically, any profit and loss question, we just remember the profit is the money in, take away the money out, okay? That's always how I do it. Money in, take away money out, right?
Yeah.
So if we look at how much money she takes, well, yeah, if we look at how much money she would take in first, okay? So that's the green stuff or the yellow stuff.
Yep.
So she's got two sources of income, the fruit cakes and the chocolate cakes. So if we look at the fruit cakes, so you can see we're sort of narrowing it down. We're focusing our thoughts. So on the fruit cake, well, she made 20 of them. So I can say she sold 20. So it's going to be 20 times however much she sold them for. So we need to have the selling price.
20 times 6.
Yeah, because it's £6 for the fruit cakes. But then there's also this caveat. Yeah, there's this business here. Yeah.
But it says 3/4.
Yeah. So 3/4 full price. 1/4 at 70% of normal. Okay. So let's process all that information. So how many is she gonna? How could I work out how many she sells at full price?
Find out 1/4 and then have it by 3.
Yes. So it's 3/4 of 20, isn't it? Because it's 20 fruit cakes.
Yeah.
So 1/4 would be
You do
5.
20 divided by 4, which is 5.
Yeah, so 20 divided by 4 times the answer by 3, you get 15. Okay, so 15 at full price. So to work out the money in from that, it's 15 times 6.
Yep.
Yeah, because it's £6 each, full price. 15 times 6 is going to be 60 and 30, which is 80. So you might, you can do it with the columns as well, if that's fine.
Yeah.
6. Oh, I'm wrong. 6. No, I'm not. I'm right. That's fine. 15 times 6 is 80, isn't it? 6. No, hang on. 60. I don't think it is actually. It is 80. Yes. 6. I'm going mad with this, right? 6
It's
times
90, isn't it?
It is 90. Yeah, it is. 60 plus 30 is 90. Thank you. Yeah, 90. So that's how much she takes in from the fruitcakes with at full price. But there's also the rest of them at 70%. So
That's 5 of them at 70%. So find out 70% of 6, and then
times that by 5. Yeah, so we're going to have 70%. So 70% of 6. Well, 10% is 0.6. So how do I get 70%?
Times it by 7.
Yeah, so what I would personally do is 6 times 7, which is 56.
Yeah, that's what I do.
And then put the decimal back.
Add in
So
the decimal points, 5.6.
brilliant, £5.60, excellent. So it's £5.60, and there's 5 of them because there's 20, 15 have been sold. So it's 5 times 5.6. Personally, I would do 56 times 5 and put the decimal back.
Yeah.
30, 25, 28. 280 is not sensible, but 28 is. So it's going to be 28.
So it'll be 28, 2.8? No, 28.
28, because you've got, think about it now, 5 times 5 is 25, so 28 is sensible. Yeah?
Yep.
Okay. So, because can you see that 5 times 5.6, it wouldn't make sense for that to be 2.8? Okay, because that would be too small. 5,
So
5
then
points.
you do 90 plus 28 to find out the total amount from the fruitcakes. And then would you minus that later by the cost of the fruitcakes?
Yeah, so this is the money in.
After that. So you'd half.
So it's going to be 108, right? 108 first. Yeah, 90, 100. Hang on, I've got
118.
118. Yeah, what am I doing? So I've been working for about I don't know how many hours now. So that's fine. It's fine. It's a pleasure, honestly, Kendra. And it's great that you're so enthusiastic to learn. It's a real pleasure. So 0 plus 8, 11, 118. So £118. Brilliant. So that's a total from the fruitcakes.
Okay.
The costs. So before we do the costs, we've still got to do the chocolate cakes, right? It's a very long question, this. So the chocolate, which is fine. So the chocolate, I mean, it's good to have a question like this because it's 8 marks, and those are 8 marks.
I feel like I'm actually enjoying this question because I actually know what I'm doing.
Well, that's the thing. It's if you know what you do, if you revise something and you get better and better at it, it's almost like it is fun. It can be fun. So 13 the chocolate cakes then. So if we now look at the chocolate cake, so I'd make a subheading for chocolate cakes. So 13 of them were sold at full price. So full price for chocolate cakes was £2 each, right? So it's 13. So for the full.
So 2 at half price.
Yes. How many? Well, so it's 13.
It was 15 in total, wasn't it? For the chocolate cakes, it was less.
I'm not. Yeah, 15 chocolate cakes. That's 13. Yeah, so it's 13 at full price. So 13 times 2.
And then 2 at half price.
2. Yeah. So 13 times 2, which is 26. And then there's going to be 2 of them. Well, if it's £2 each, that's going to be £1. Chocolate cakes £2 each. So it's going to be. No, it's not. It is 2. 2 times 1, which is just 2. So the total then is 28. Yeah.
26. And then so this is full price. And then half price.
Yeah, that makes sense. The total for 118, chocolate cakes 28. So we can work out the total income, the total money in is 118 plus 28,
Hold on.
16, 2, 3, 4, 146.
$146. So then we do the money out.
Yeah, brilliant. So money out. So for the money out,
Let's
we need to
do
look at the
fruitcakes
costs.
first.
Yeah, so for the fruit cakes, we've got to look at the costs. So cost was half of the normal selling price.
So
So,
£3.
yeah, and how many did she make?
£3 for each cake, which was 20. So 3 times 20 is 60.
Yeah, brilliant. So that's going to be £60, how much it costs to make all the fruit cakes. And the chocolate cakes would be how much?
Hold on, I'm writing this down.
That's right.
Okay, I've done it now.
Okay, brilliant. So the chocolate cakes were how many? 15 times just one, isn't it?
So it's £15. So the total cost of making the cakes would be £75.
Yeah, £75.
So then you work out the profit and loss. So you'd be 146 minus 75.
Yeah, that's actually quite a good profit margin then, actually. So that's pretty good. So so £71. Yeah, there we go. So profit will be £71. I'm gonna just check the mark scheme there because see how they would mark it.
I feel like I understand it enough now that I don't really have to do another one.
Oh, that's
Because
brilliant then.
it's just the same with the fractions, but obviously you just change the fraction to a different number. You do the exact same thing.
Yes. So it's the same thing. It's just obviously different, ways of working out.
Different numbers, yeah.
Yeah, but so percentage you work out 10%. Now for some reason it is 64. So let's see where we went. Right. So 75 was right for the costs.
Yep.
The only thing was the money in. 90. We had 90. Had that. So to be honest, we probably would only lose one mark. 21.
Oh, where would we have lost that one mark?
It is that we had a 28. That was right. There's a 28 that we had that should have been a 21. 5 times 5 points. That's 5 times 5.6. That's wrong. So money taken from reduced price. It's the fruit cakes. It's the fruit cakes. We got it wrong. So the fruit cakes, reduced price fruit cake. So that we know exactly where it is because our workings are quite organised. So it's somewhere here. Let's see where exactly.
70% of 6.
If anywhere, it's probably going to be there. So 10% is 0.6, 70%. Oh, 7 times 6 is 42. I did 8 times 6. I did 8 times 7. Can you see
42,
that there?
okay.
So that's easy enough. So that should actually be, I knew there was something, so £4.20. So we change that to 5 times £4.20. So you can see this is why it's good to have organised workings, because if I was in an exam looking through, I could just very easily change that.
So the total from the fruitcakes would change.
Yeah, I mean, 5 times 4 is 20. 5 times 0.2 is 1. So we end up with 21.
Yeah, okay, yeah.
Because
Makes
0.2
sense.
is a fifth, so
So
5 fifths
instead,
are 1. So total for fruitcakes is
so
going
instead
to...
it's 111.
Yeah, because it just reduces it down to... Was it 111?
Yeah, 111.
Yeah, of course, 28, 20... Yeah, of course, there you go. Yeah, exactly. It's got to be. So 111. And all that does, that changes the money in there. That changes it down to 111.
139 in total money in, and then you just do
Takes off
139
70.
minus it.
Yeah, so very, very
Oh, it wasn't that
straightforward.
bad a mistake then. It could have been
No,
worse.
it's a there's no conceptual mistake. It was a simple. It's an arithmetic mistake, and you would lose an accuracy mark. You wouldn't lose any more than that.
Wait, so what was the final answer?
64.
Oh, okay, I did get 64. We're okay then.
Yeah, so 5, 4. So yeah, easy. That's it. So 64. So you only lose 1 mark. I'll show you they break it down. You would literally lose. Do you see that B1 mark there? You'd lose that B1, and that would be it. And everything else, the FTs, would be followed, but it is contingent upon you writing the workings and showing them that. Because if you just put a final answer, imagine if you just put a final answer of whatever we had. We had like, what did we have? We had like 70 something.
£71.
Yeah, exactly, because we were literally off by £7. So, but if you just put that, you would get 0. So and in fact, if you just put 64, here we go. So a final unsupported answer statement only get QWC 0. So that means you would lose 2 marks automatically. There'd be 2 marks that you would never get. Okay. Yeah. So look for
What if you
relevance.
managed to guess and got the answer right? Would you get all, like, how many marks would you get if you guessed and got the answer right?
You would get 1. So if you look at this, look, it says
Yeah,
A1.
that's
Do you see that
brilliant.
CAO? That CAO
Yeah.
means correct answer only. So, in fact, we would probably have lost 2 marks. Quite mean, actually, for making that slip, because there'd be the B1. Actually, no. Would we get B? I don't think you get the B1. That equals 21 business. Although, actually, no, you would, to be honest, because the B1 is saying 5 times 0.1096, which we did. So we would get the B1. The only mark we would lose is that A1 mark.
Oh,
But
okay.
at the same time, if you just wrote 64, you would only get that A1 mark. You wouldn't get any of these other marks.
Yeah.
So, okay. So, do you want to go to another one, or do you want to leave it there for tomorrow, Kendra?
I think we'll leave it there because I think I understand now.
Well, that's
And I
brilliant.
can like look at some more questions.
Yeah,
if
of
I
course.
feel like I
And
need.
I can tell you the questions. I downloaded if you want, but that's brilliant. Okay, so
Okay.
question bank is
Oh
really
yeah,
useful.
send it to me and I'll do it on my own and see how I get on at some point.
That's great. Okay, so that's brilliant, and I'll send you the recording as well. But if there's any issue, ever any issues, Kendra, just let me know. Okay. All right.
Thank you.
Have a nice evening now. Bye now.
Have a nice evening too. Goodbye.
Bye now.